Hey guys, what's up? Today we are going to look at understanding. So, when we look at this, what do you think? Okay, five people are participating and there are five positions. You have five positions, and they all want to be president, but we can't have more than one. So, after one is chosen for president, the other is chosen for vice president, the other is chosen for general, the other is chosen for secretary, and then for the bureaucratic official, right? So, that's where this equation comes in. Because you have to see it like, okay, so there's five people that can be chosen to make to be president. Five people can be chosen. But once that's gone, then there are four people, and then there are three, and then there are four, two, and then there are one. So after the three and the four. So you would, if you had to solve this, it would be technically a 3 times 4 times 5 times 2 and times 1. I said it out of order, but that's how you look it at, which is equal to something called, which is equal to 120 or 5 factorial. That's what it's called, 5 factorial. This exclamation point symbol you see in your calculator means factorial, and that's what it represents. This here represents a factorial. 6 factorial means you multiply a 6 to this original equation. Like if you did this, this would become, you would just add times 6 time, okay, it would be shift times 6, and then this would change, and it'd be 720, and then you get a 6 factorial, like that. It's basically like that. But that's what a permutation is, and order matters in that equation. But if you ask something like a pizza topping, like you have for 5 pizza toppings, okay, let's just say pepperoni, which I'll write P because I don't like typing at this moment. Pepperoni for P, cheese, which stands for C, uh, onions, lettuce for L, tomatoes, and let's just say olives. I'll write olives out. Olives. So pepperoni, pepperoni, cheese, onions, lettuce, and tomato. Okay, you have to choose 3 of them in any order. So if you want pepperoni, cheese, onion, and lettuce, let's just say, or pepperoni, cheese, and onion, sorry, that's what I meant to say. You can say cheese first, then pepperoni, then onion, or onion, then pepperoni, then cheese. It doesn't matter. It would still be 3 choices out of 5. Sorry, 6. So it would be 6. So let me write this 6. 6, make it tiny, like really, really tiny, like 10. 6, 6, and then I'll just make this like a 12. Choose, and then I'll copy this, copy, paste, and then just make it a 4. So like 6 choose, sorry, 3. Why am I clicking 4? 6 choose 3. That means out of 6 options, you choose 3. While in here, it would have been 6P6. Because like you're doing all 6 positions, and also, yeah, it would be 6P6. That's how you write it. So that's how you think of it, as a permutation and a combination. One order matters, like the president, vice president. You have to have one position. And once one of them takes that position, another one cannot take its own. But in a combination, it does not matter. Like it's like the pepperoni toppings. It doesn't matter whether you said cheese first or pepperoni. You still get pepperoni, cheese, and onion. So like that, in that order. And another concept we have to introduce is independent and dependent. So some cases you will see that it may be, what do I say? Some cases they don't mention if it's a permutation or a combination. It doesn't mention, and you have to think of it. It's an independent or a dependent. What happens if something is an independent or a dependent is that if it's an independent reaction, or sorry, an independent event, then the first event does not help determine the second event. The second event is not affected by it. So if you say roll a dice, if you roll a dice for and you get two, and then the second time you don't get a two, it doesn't matter because it's a fair dice. Rolling a dice does not may change the effect of the first one or the second one. If you roll a two first, does not mean you're going to get a two the second time. There's no dependent variable already established for that. But in a dependent variable in a first event, it would be like saying, oh, I have a large group of marbles. Some of them are red, some of them are blue, and some of them are green. If I take one marble and I don't put it back in, that's a dependent event because once you take that marble out, let's just say you took one green marble out and you didn't put it back, it is a dependent event because now when you try to find a probability of taking another marble out, it will decrease because you already took one out and you also took one of those colors out. So if I took one green out, then didn't put it back, and then I took another green out, then already it's a dependent event because it depends on whether you put the first one back in or not. So those are the two concepts that I wanted to introduce. And a few questions that I'm thinking of are some examples that my teacher had shown. And this would be a good one that I would like to show you is that if you roll a fair dice, if you roll a fair dice, and in one case, one of the, and you roll this, and you roll this into two, to roll this twice. That's what I was looking for. What is the probability that you will get a 2 and then not a 2? Now I'm going to get my drawing highlighter out here. And you can consider this in one way, which is as like there's a few methods, but this is the method that I personally chose. So let's just say I'm going to draw this basic shape. And now what I'm going to do is that I'm going to do, since there's, how many spots are there on a dice? There's 6, right? So 1, 2, 3. That 3 was really bad. For a 3, that was really bad. 3, 4, 5, and a 6. And I do 1, 2, 3, 4, 5, and 6. Oh, I hate that 6 so much. So what's the probability you will get to roll a 2 and then not a 2? So there's 2. So you can get a 2, not a 2, 2, 2, and this. So it'll be, so if I use my highlighter, it would be this color, let's just say. I would do la 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 la. So 1, 2, 3, 4, 5. You don't get the 2 here. Or you could get the 2 here, 2, 3, 4, 5. So how many choices do you have? You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10. Out of how many choices? 6 times 6 is 36. Now that may be a simple problem that I would like to show you. Another problem would be that if I take out my drawing and I go back to this, yeah, is that if you roll a dice, if you roll a coin, a fair coin, and you get at least one heads. I'm going to change the problem up. This problem my teacher showed. She showed it in our class, so it was good. So at least you get one heads. Now, this is an interesting question because it is a really fun way to solve this. Because let's just consider one thing. So at least one. And if you, let's just say, I'm going to roll this coin, rolled 5 times. Amongst the 5 times, you need to have at least one head. So what does that mean? It means that you can get 1 head, 2 heads, 3 heads, 4 heads, or even all 5 heads. Now, if you don't want to do all that work and figure it out because you're like me and you want the shortcut, this is the way I would solve it. And this is the most simplest way, so I personally think that you should do it this way. So let's find the probability of just being all of it being, sorry, not this, all of it just being tails. None of them are heads. So how many possibilities are there? It's one out of many, many, many solutions. It's 1 out of 25. Sorry, no, I'm wrong. Go back. 1 out of 32 because you rolled a fair coin and a fair coin has 2 sides. You roll it 5 times. That means you get 32. It's actually equal to 1 over 2 to the root of 5. And then what you think about it is that this value means that anything besides that, you get it completely correct. You get it completely correct. So that means if you didn't have any heads, this is what you would get. But you want to find at least one head. That means anything besides no heads. So you just have to do 1 minus 1 over 32, and you get 31 over 32. If you're in my class, you already know these problems, but this is the few problems that I really thought were interesting and I really liked. And another thing I wanted to introduce before I ended this video is that when you think about a combination or a permutation, always think about how it is applied. Think about how the question applies it. So I have 5 questions down here. Does the order matter? Why does it matter? Does it action 1 affect action 2? How many possibilities are there? And why are there that many possibilities? So these quick questions, I just wrote them down ahead of time. But these 5 questions should always be in your mind when you solve a question related to probability. Is it a permutation or a combination? Why is it a permutation or combination? Is it an independent event where one action does not affect the other, or is it a dependent effect where one action does affect the other, like the 2 equations I showed? How many solutions are there in total? Are they asking about it in total, like the entire thing? Or is it like with this and this already applied, saying that instead of saying, oh, all the solutions, if it says it's already going to be defined as 1, 4, and 1, 1, no matter what, or a certain, what do they say, defined domain, you will understand it when you see a problem. And I would broaden up on that a little bit later. But if you see it in that case, that's how you would do it. And why are there that many possibilities in that concern?